Kia ora everyone, welcome to our next video in our series of organic reactions, this one on oxidation. First of all, let's take a look at a couple of examples of oxidation reaction. Rust on a car being one of them, and fruit or food browning or spoiling from being exposed to oxygen, both examples of oxidation. Although in redox we define oxidation as the loss of electrons, in organic chemistry we tend to think of it as adding an oxygen atom, or better, forming more bonds between carbon and oxygen. In level 2 chemistry, we need to know two oxidation reactions. The first one is starting with an alkene with a C double bond to C, and we add K-MnO4 or potassium permanganate, which creates a diol. Two OH groups where the double bonded carbons were, adding two carbon to oxygen bonds by our previous definition. And the other reaction we need to know in level 2 is from a primary alcohol. And we can either use acidified permanganate or acidified dichromate. And what happens there is we create a carboxylic acid. See that what we've made is two more bonds between carbon and oxygen atoms as per our previous definition. In level 3 oxidation, starting with the primary alcohol again, we have to add in an extra step that we don't need to know in level 2. So if we look at this alcohol here, it's a primary alcohol, again adding acidified permanganate or acidified dichromate with heat. The first step we make is to make this aldehyde here. On the same carbon, we've added an extra bond between the carbon and the oxygen, so now we have two. And further oxidation with the same substances will give us the carboxylic acid, which now has three bonds between the carbons and the oxygens. We'll have a look at this reaction in much more detail when we look at techniques used in organic chemistry later in the topic. Next, let's take a look at a secondary alcohol. Oxidation involving dichromate and permanganate, again, also with heat and acid, but this time with the OH on that central carbon bonded to two other carbons, it actually produces a ketone as its product of oxidation. You can see that there's an extra bond between a carbon and an oxygen in the ketone compared to the alcohol, although we haven't actually added an extra oxygen atom. The next one that's obvious to look at is the tertiary alcohol, where the carbon with the OH is bonded to three other carbon atoms. Tertiary alcohols are unable to be oxidized because we cannot add any further bonds between carbon and oxygen, as that carbon already has four bonds around it. Lastly, in level 3, we need to also know reduction reactions. So looking at butanone, we can reduce this with sodium borohydride, NaBH4. So what happens there is the opposite to oxidation, where we reduce the number of bonds between carbon and oxygen. So you can see we've gone from 2 in the reactant to only 1 in the product. And note also that the alcohol group is on the same carbon atom as the carbonyl group, the double bond to O, was in the original ketone. You can also do this reaction from an aldehyde, and that will also reduce to an alcohol, but the alcohol will be on the end carbon. And the last thing that's useful in oxidation are the observations. So permanganate is purple. When reacting with an alkene, the purple decolorizes. With an alkane, it doesn't. So permanganate can distinguish between an alkene and an alkane. When reacting with alcohols, the permanganate will react with a primary and a secondary alcohol, so we'll go from purple to colourless, and will not react with a tertiary, so the purple will remain purple for a tertiary alcohol. The observations are different if you use dichromate, which is orange. Dichromate is not a strong enough oxidant to oxidize an alkene, so we're just looking at the alcohols. The orange turns green for a primary and a secondary alcohol, as seen here, but stays orange for a tertiary, indicating there's no reaction. And that's the end of this video.